Hello, can you guys hear me now? Okay, so I'm gonna mute everybody. That way we don't have any background disturbance or anything. So that should be good for now. All right, just confirm once again that if you're able to hear me. I think it might be in my laptop issue. All right, awesome. Cool. Okay, so it's just three. So what we'll do is we'll go over a couple of things today, specifically focused around design mainly. And when I say design, I don't really mean UI or user experience, but I mean how to think about when you are going to design your code. So this is something that I just feel that gets overlooked by developers the most, because whenever you say design, everybody starts to think, oh, we're talking about either game design, UI design, UX design, things like that, right? But there is a big field of design which is how you architect your game, how you architect your project, how do you think about making systems. So that's more important from a developer's perspective. So when you're a developer, um, you should always be thinking about design. Not to mention that of course you should be thinking about game design. That's also very important. But this is the part of design that nobody else will think about, but only you have to think about it. So one of the uh, one of a very famous author, he used to say this key. If we have a doctor and we say, hey doctor, just don't wash your hands, just treat me like that, right? But if they start doing that, then they're not holding true to their professional world, right? They're not maintaining their standards. So the same goes for us developers as well. So um, our project managers, our teammates will always push us to make code fast, um, because they don't care about code quality. But if we want to be professionals and we want to be treated like professionals, we need to make sure that our code quality remains world class. So we need to start taking it seriously. Cool. So what? Okay, wait just 1 minute. Couple of more people joining in. All right, awesome. Okay, so since everybody has seen a small summary of what we're going to be talking about, we'll start off with the most common design pattern, which is the singleton design pattern. And anybody who's done any kind of coding whatsoever would probably know what Singleton is, um, and would have used it in some shape or form, no matter what. So from Singleton, we'll first look at why it is important, how people fuck it up most of the time, and how we can fix that. And from there, we'll move on to a very common yet overlooked pattern called uh, model view controller. So some of you might be familiar with what MVC is. They might have used it, they might have not used it. If you used MVC or Singleton, just let me know in the chat. Would like to keep this session as interactive as possible. So that way we can get a sense of what people already know and take it from there. Cool. So let's get started with, first of all, the Singleton design pattern. Okay. So quickly, just type in the chat if you yes or no if you've used it or not. And when I say Singleton, it just basically means, you've created an instance, which is basically a static instance. That's the most common form. Okay, cool. So yeah, as you can see, there's so many people saying yes. And I'm sure if I ask a lot of them to just share their code pieces, there'll be a lot of issues in there. Cool. So basically, Singleton, all it says is that only a single instance of a particular object will ever exist uh, during the entire game slash app slash whatever it is that you're building. So when you say a single instance is going to exist, um, there are different ways to enforce it. So let me quickly share my screen as well, and we'll jump directly into some basic coding. All right. So, okay. So can you guys see my screen and the code editor? Let's give me one sec. This share screen thing is. Let me get this fixed correctly so I can see the chat as well in parallel. All right, cool. So, all right. So here you see Singleton, right? So you see this class called mono Singleton. Now the way this works is that typically what you would see a developer do is when they create any class and they want to make it a Singleton, they'll start by creating some private and name it. Uh, you'll call it static mono Singleton. So mono Singleton is the name of the class. You'll call it instance, and then in the awake method, they'll just go and say instance is equal to this, right? So that's the most common way that you'd see developers use the Singleton pattern, right? But essentially, there are a lot of issues in this one. Would anybody care to explain here? So if I have this particular thing on a game object, it's a mono behavior, I can attach it on a game object. Um, right off the bat, you can just see that this is not really. It is loosely a singleton, but I can go and create a duplicate game object, attach another mono singleton to it, and it will still work. So in that case, you'll end up with two instances of it. and two instances will exist in parallel. Uh, so it's not gonna be a pure singleton. Um, okay, cool. So we have some people joining in now. So we're talking about the singleton design pattern, right? So what you see on code, this is the most basic form of singleton, and this is the first mistake that I can have this particular script, attach it to two particular game objects, um, and on two different game objects, and both will just work fine, right? Um, so that's the first problem. Secondly, so if I say, the second level that I see devs doing is if instance is not equal to, or rather say if it's equal to null, right? And then they'll say, oh, so that means there isn't an instance of this particular singleton that exists. So now I'm gonna mark this instance as this, okay? So this is better than the previous version, but again, it's a problem, right? Because even now, all we are saying is that whichever is the very first object that gets created of this class mono singleton, that's the one that this instance is going to hold, right? So the first time when instance is null, we'll assign it value. But if I keep duplicating these game objects on which the script is attached, right, the second one, its awake, is going to get called, just that it will not pass this if. But we haven't defined what happens when this instance is not equal to null. When somebody is trying to create an instance and an instance already exists, that means somebody is trying to create a duplicate instance, right? So far what we have done, this is definitely better than the previous version, but it still doesn't solve a problem. So essentially what we want to do is we want to define an else case. An else case means that we have an instance and that instance already exists. So somebody somewhere created this singleton before us, okay? So in this case, we'll say, instead of doing anything with this instance, we'll just say, we want to destroy this object. That means something is trying to create a duplicate object when an object already exists, okay? So an object already exists, and we said this is a singleton object, only one should exist. So anytime a new object, somebody's trying to create a new object, we won't let them. We will directly destroy it, okay? So that's the most basic implementation of singleton that is actually correct. So this is the least amount of stuff that you can do to make sure that when you say that I've implemented a singleton, that it is actually a singleton. If you don't have the else condition, again, your singleton is not really a singleton. You're just saying it as a singleton because you've created something called static instance. And that doesn't make it an singleton. Okay, so now we're making sure that anytime somebody is trying to create a duplicate, we're going to destroy it. Probably we also need, since this thing is public, this particular thing is private, people need to access this particular singleton from outside. So we'll create a public property, and we'll call it something like this. So we'll say return instance. Now, anytime from outside this particular code, if I want to access this particular class, I'll use this instance and not this instance. What this ensures is that my actual instance is private and it can only be controlled inside this class. Nobody outside this class can change it. So what would have happened if you say, did this and made this public, which most developers do, right? So you'll see public static mono singleton, and then there's an instance, and you do this. You're like, hey, I just created an instance. I'm destroying anything, but since this is public, anybody outside can also change it. So we don't want to do that. So instead, we want to make this private, and we want to make sure that we expose a public property on which there's only a getter. What this getter says is I can only read this instance value, and whenever somebody's trying to read this instance, they'll get access to this, but nobody can change it from outside this class. So anybody outside this class will not be able to change uh, anything to do with this instance. Okay. So now we've understood what the basics of a singleton is. Okay. Um, there are a few things more that you can do. So now what will happen is, let's say if you have a game controller or a world controller or level controller, anything like that, right? Like any kind of scripts, UI manager. These are the most common names if you build any kind of games before that you see. So people will end up just literally copy pasting this entire piece of code in every script that they want it to be a singleton. Okay. And that's bad, because if tomorrow I find that, hey, my this 15 line of code had a bug, right? So there was a bug in there for some reason or whatever. So and now I need to fix it. So if I have 20 different singletons in a project, then I have to go and change in all those 20 places. Okay? And I don't want to do that. So what you will do is, now here comes the best part, right? So I don't know if everybody's familiar with this as a notation. So when you say something like this is called generics, okay? And I'll just go into a little bit of detail about what this is. So bear with me for 1 second. And I'm just gonna, you know, uh, finish writing this, and I'll just explain in 1 second what this means. Okay, so ignore all of this for now. So what we've done is we have created a mono singleton. We have given it a generic T. So earlier, if you look at our previous implementation, we just said mono singleton is a mono behavior. That's all, right? And I could have created another class that inherited from. Uh, Actually, let me just create that. Okay, so let's do this so that it's clear. So this is our first version of mono singleton. Okay, so I'm gonna create a new mono behavior. I'm gonna rename it to mono singleton generic. Okay, so I'm gonna remove all this, and now I'm gonna say this is a mono singleton generic, and this has that same T thing that we just saw. Okay, so here you see I'm saying a mono singleton and this. Now I could have created a separate, I'm just typing it here, but you imagine this is a separate, so if you have a game world class that was supposed to be, say, a singleton, so you could have done something like mono singleton, and now this game world class is inheriting from mono singleton, so it's getting all of this code as well. So in another class, I can very well, so if I create, let's say, another class, which is, say, the world, and that's a mono behavior, or rather a mono behavior, rather, not a mono singleton. So if this is a mono behavior, then inside this mono behavior, let's say inside the awake function, I can say game world dot instance. I need a object of, why is this giving me an error? An object reference required. Oops, sorry. So since this is a property, this needs to be static. So now here you see I'm able to access this instance directly, and So if I had like a function here called, say, public void play game. Okay, so this instance would let me actually call this function directly like that. So, oh, see, this needs an instance object. So this instance is not getting created, that's why. But you get the idea. So the idea is here is that I can create an instance if I move this actual logic. One second, let me just cut this here and paste it here. So now you see I can actually call this function, right? Because from this game world, since it's inheriting, I'm able to access this instance which is in the base class. But here you see this problem, right? That this play game function was not meant for this particular base class. It was meant for this particular game world class, and I can't put it there, right? So to avoid copy pasting all my code in 30 different classes, or however singletons I want to create, what I want to do is I want to go to this generic implementation. And what this generic does is it lets me, so when I define this particular thing here, right, that a game world inherits from a mono singleton, instead I want to say how it inherits from this mono singleton through a generic behavior. Okay, so here I would say, just I'll explain this, what this where means. Just bear with me for a second. And so this is not mono singleton, this is mono singleton generic. Okay, so now essentially I need exactly the same piece of code, but I'll make some key changes here. So here you saw, right, we just copied exactly the same thing over. But instead of this instance being an instance of mono singleton, we'll make it an instance of this type T. So all we're doing is we're defining this type T here, and when somebody wants to inherit from this mono singleton generic, they'll tell us what this type T is. Okay. Now this lets us create functions very easily. Okay. So here I have to typecast it to T, and now you see there's no errors here. Okay. So now I'll create the same thing here, and you'll see that this will work. So now you have this mono singleton class. I'll create this game world class, but now when I'm creating this game world class, I'm defining that it inherits from mono singleton generic, and it is of the type game world. Okay, so when I say game world, instead of this T, I've given game world here. Okay, so yeah, let me just remove this out. So what this means is that game world inherits from mono singleton, passing game world itself as this parameter T. So when this instance gets created, it's not getting created of the type mono singleton, it's getting created of the type game world, if that makes sense. Okay, so think of it as this is getting passed in place of T, and in this entire class, wherever you see T, okay, imagine that that's actually getting replaced by game world. So if now somebody calls this instance, they're getting an instance of a game world. Why is this? So this is because of namespace. Just call it game world new. So here we'll say game world new. So now this suddenly this entire class with just this much addition has become a singleton that inherits from a mono behavior and nothing else. So imagine if this piece of code was sitting in your project in a separate script. So I have this mono singleton script, it's sitting there, and I go and create anything in this game. So I create a new script here and I call, move this code there. So with one line of code, my entire script became a singleton. And anytime if I find a bug or if I want to add something, let's say I want to always know that if there is somebody trying to create a duplicate object of a singleton that exists, right? So someone trying to create a duplicate singleton, okay? And I'll mark this as, instead of a log, I'll call this as a log error. Okay, so now with this one line of change, if I have 20 different classes like this that are using the singleton property, every object will start showing me this error if somebody's trying to create a singleton that already exists and they're trying to create a duplicate singleton. Okay, hopefully it's making sense. So creating this generic, and by generic, it means that this can be an integer, this can be anything, right? Where we have just said that we can pass in anything here. And that anything will basically become a singleton. So I'm going to rename this world to new. And now say inside this, I want the start function. Okay. So now imagine I want inside the world, when the world starts, I want the game world new function, and I'm going to call instance on it. And I'm going to call, say, there's another public void start game new function here, let's say. And that will show me up here, start. So you see start game new, start game new. All right, and done. So with just this one line of code, I've turned this entire class into a singleton. Okay. And if there is any error, I just change it inside this class and I never have to touch it again. So that's the power of object-oriented concepts if you use them correctly. So what we are doing here, we are using generics. We are using the singleton pattern. We are creating new instances using these generics. We are creating, and this is basically an inheritance relationship. So we have defined it as an inheritance. Okay. So this, hopefully it is clear how this can actually work. One extra thing, and this is slightly an optional thing as well, that it doesn't really need to be as part of everything else. So if you have any questions so far, just put them down in the chat right now. And I'll tell you meanwhile one more thing. So what you can do is, if you want to even take this one step ahead, right? So you'll be like, hey, I know, Mayank, I created this mono singleton, which is a generic class, but it has this awake function. What if I need awake inside my game world new class as well? What if I wanted, access to my awake function here as well, and I wanted to do something in awake? If I'm doing inheritance, awake has been defined here. Now I've defined it here as well, which means I've lost whatever was happening here. So what we'll do is we'll use the override keyword. Virtual keyword here. What this lets us do is basically, it lets us, cannot be private, so we'll make this protected. So what this means is that we have said that anybody who inherits from monogeneric, we basically will be able to override this definition inside the child class, but also be able to use this existing functionality and not have to duplicate it. Okay. So what this means is I can here very easily say base. So you see base show up. This is a keyword, and I'm going to say base.awake. Okay. And here I'm going to say override. So what this is saying is this private. Instead, it should be protected. So what this is saying is that if in my game world, I needed to do some custom logic on awake. Okay, so I needed some custom logic here. So I needed this awake functionality. And now I have the power of using this virtual keyword. Virtual just says that somebody who inherits from this class has access to overwriting the functionality inside the awake. So in case for some reason I wanted to create a mono behavior that completely overrides this particular functionality altogether, I just need to remove this base.awake here. But if I want to make it a singleton, I want to reuse this functionality and not have to copy paste it every time, just this base.awake. All this is saying is that whenever this awake gets called, first this awake will get called. Here, the very first thing means base.awake means it will go to the base class, it will execute the awake logic there, and then it will execute its custom logic. And you can very well change the order as well. If for some reason you want your custom logic to get executed first before the parent class logic, this is purely how inheritance works, right? So function overriding typically. So that's all there is to it. This has nothing to do with as such, unity or anything to do specific to game development. This is exactly the same concept that you'll take if you, let's say, wanted to create some other class, a Java object or anything like that, right? So if you're coding in any other language, it would still remain the same. The functionality that you're seeing here will exactly remain the same, and a small class like this can give you an infinite power of turning any object into a singleton. Okay, cool. Rocky said base.awake. Yeah, that's correct. So, but normally your flow would be base.awake first, which means execute the base logic and then put custom logic on top. Okay, so let me quickly see. All right, does anybody have any questions so far? Let me just come back to the screen and see. Okay, so quickly, if anybody has a question, you can like raise your hand feature kind of thing that you can use. Otherwise, we'll move on to the next piece, which is the model view controller. Nope. All right, looks like nobody has questions. So everybody understood everything? Okay, so HP is asking, can we have multiple singletons separately? Say an audio, UI, etc. Yes, that is exactly how you'll have it. So what we have done so far is, all we have said is that this particular base class that we've created, I can inherit from it and create a separate singleton out of it. So if you have something that handles all the audio, you can create an audio singleton for it. If something that handles all the UI, you can create a UI singleton for it. Okay. And actually, I think let me spend a little bit more time about singleton itself, because this is probably the most overused design pattern, and a lot of people don't understand the problems that it can cause. Okay, so actually, let me come back to it once we cover the model view controller, because both are kind of interlinked. So I'm going to use this whiteboard over here, and just tell me if you guys are able to see it. I'm not sure if it will be available on directly YouTube. We'll try to upload it, but we are recording it, so it will be accessible in some shape or form later. So don't worry about that. Everyone who's attending the session will definitely get access to a recorded version. But it might take some time to upload it either to YouTube or someplace else, or so we'll definitely share you access. All right, cool. So let's quickly jump over to the model view controller. So Just raise your hands quickly if you know what MVC is, or have used it, read about it, anything. If you're familiar with what model view controller is. Okay. Doesn't look like anybody is familiar with it. All right, cool. So I'll start from the very basics. And so what is model view controller? Can everybody see the whiteboard? I think I might have to move it a little closer. All right. Okay, so basically it might be too high. Right, a little lower. So we have something called as a model, we have the view, and we have the controller. So this is something that was popularized by the Microsoft ASP.NET architecture, but it's been used pretty much essentially everywhere, right? I see that the light has a reflection on the screen. Are you guys able to see this correctly or not? Can you guys see this? Okay. Yeah, because for me, the board is giving a little bit of a light reflection. Okay, cool. So what M stands for model, V stands for view, C stands for controller. So what this essentially says is that anything, essentially, I can break it down into these three core components, okay? So like the name says, view essentially refers to anything that's UI related, okay? Model is anything that's specific to the data part, okay? And the controller is essentially my core behavior or business logic or anything like that, right? So these are my core pieces. So, okay. So anything that's UI related will go into the view. Anything that's data would go into the model, and anything that's more of logic will go into the C, which is the controller. Okay. So typically, the way the flow works is you have your C, M, and V. Since controller is the logic, it basically kind of talks to both of them. Okay. So this is the logic that defines the entire behavior. So this is the thing that talks to both of them. View is anything that's related to the UI. So when you think of in terms of Unity, this is where your mono behavior stuff comes in, right? Because anything that's a mono behavior is attached to a game object, and so it has some representation in the game, right? Whether it's a UI element, whether it's a player 3D character or whatever, right? Whatever is visible on the screen, that is the view part. And then whatever is the data portion of it goes inside the model. So typically what ends up happening is that people who do not use MVC, all they do is they just create views, right? So if you are supposed to create, say, a lobby or a game world, right? You'll create a game world mono behavior, right? You'll create a player, movement mono behavior or something, right? And things like that. So all of your scripts are mono behaviors, and they'll have the business logic, and they'll hold the data as well. So all of this is put inside the view. And essentially it's Unity's fault as well. They never really explained this correctly, that there are better ways to create things than just by creating everything inside the mono behavior. So typically what we end up doing is, So far, everybody, if you have like 10 scripts in your particular project, 10 of them would be just mono behaviors, right? But that's actually not the right way. That's not the most performance good way. That's not even needed in the most cases, right? Maybe 3 scripts out of all the 10, you end up needing mono behaviors, but rest you can actually very well do without a mono behavior. So if you think back right now on the mono singleton stuff that you were creating, the other classes that I created, they weren't mono behaviors, right? They were just simple classes. Anybody can create an object of those classes. You don't need to create everything as a mono behavior. So I'll take a very simple example, and this is probably the most common one, right? So imagine if you have some kind of a tank battle game or something, right? So you have a tank. You want to create a tank. Typically, what people do is think of it as if you're the player who's controlling this tank, right? Typically, you'll end up creating is a player controller class that will inherit from a mono behavior, and that will have all the tank logic. You might call it player controller, you might call it tank controller. Both are roughly the same thing, but the idea is that there will be one big class which will have the entire logic inside it. You'll have the update function that checks for inputs and whatnot. You'll have your collision detection functions and whatnot, everything in there, right? And now you'll end up with this 500 lines of code in one class in just one day. And if this is a project that needs to continue for 2 years and you keep adding more stuff to it, eventually this class will become 5,000 lines. And it will be a nightmare for anybody to add anything to it. It cannot be tested, and it's just a headache for everybody. Okay, so we'll use MVC for breaking it down. So what we'll do is we'll create a tank controller. Now this tank controller is not going to be a mono behavior. We will not create it as a mono behavior. It's just a simple class, public class tank controller. That's it. There's no mono behavior, none of that nonsense. All right. We'll create a tank view. Now this will be a mono behavior. All my UI for the tank, if it's a 2D tank, all the sprites and whatnot. If it's a 3D tank, then what is the model or prefab and everything. So this is the one that will get attached to the game object. This is the one that will be on the prefab, okay? And then you'll have the model, tank model. So what is the speed of my tank? What kind of bullet does it fire? How much is the firing rate? All that information is gonna be inside the model, okay? So this way, now I have essentially broken down that one in single, player controller / tank controller that you might have created before into these 3 different components. This is not a mono behavior. This is not a mono behavior. Only this is a mono behavior. Okay. So now you see how we are splitting this code up in order to make our life easier and simple. So if I have, say, another script, when I hit the play button and the tank needs to spawn, okay? So typically the way the flow will work is somebody will create a new tank controller. So somebody will call new tank controller, and inside this new will create a new view object. So when we create a new view, that is basically saying instantiate a view in Unity lingo, right? So we'll have some reference of a prefab that represents our particular tank, and that prefab will basically be the tank view. Okay, so this will be nothing but my prefab. Now, what this prefab is will actually come from here. Okay, so when I say new, I'm just not going to call new directly like this. I'll pass it an object of a model, and I'll pass it some data about the view. This might be the direct link to the prefab or something like that, but something that lets it know that what particular tank do I want to create. So tomorrow, if I want to create 20 different types of tanks, right? Anything inside the controller doesn't need to change. Anything inside the view doesn't need to change. Only this one line which knows that which prefab I'm supposed to pass in here, or which particular tank ID, or however we are identifying these 20, 30, 40 different types of tanks, that just needs to change here, and naturally everything will flow down. So somebody will call new, that new will go inside here, that view, the prefab instance will get passed here, this will get passed here, and here it will create a new instance of that particular prefab. Okay. And similarly, if let's say I want to create a basic tank, but a user has a speed boost available that he's using, right? So I'm gonna create a different model. Since it's another different class, I'm just gonna say new model and pass it 2 times the speed, right? Instead of just 1x, I'll pass it 2x. So that way, nothing else needed to change. Anytime I was just creating a new instance of it, all I said was I'm going to pass in a new, uh, a simple object which takes in double the speed. So for this particular tank controller, all it knows is this is its normal speed. It doesn't care. It just says that, hey, somebody told me that I need to create an object which has twice the speed. I'm just going to create it. Okay. So hopefully this explains how a little bit of things work. Now, typically, once you have created a tank controller, a tank view, a tank model, how normally a behavior would go is that if you have a logic to detect, say, button presses or left and right movement or joystick or anything, all that logic will be inside your tank controller. Or some people like to do it is they put it inside the view, because if you're doing it in every update, since view is your mono behavior, it is getting that update. Every update it is checking if input dot blah blah, right? So anytime it sees that there is some change in the input, it will let the controller know with one function call that, hey, user press the right button or user press the left button. And then the controller will see what it needs to do, right? If I'm saying move forward, and then suddenly I say move back, the controller implements all the business logic. All the logic goes inside the controller. So the controller says, oh, okay, now I need to change direction. So it will update the model and say, oh, user was going forward, now it's going back. So if there is an enum here that says direction, instead of forward, it will say back, and it will tell the view to change the direction. And then the view will change the direction. View doesn't know what it needs to do itself. It only relies on the controller to tell it. Okay. So if this is a little bit confusing or anything, just I'll just take 1 minute. If anybody has any questions, just please raise your hand. Because this can be a little bit confusing to people who are looking at it for the very first time. Because the most common thing is like, hey, I could have just done it in one script, right? Why do I need to do it in break things into so many scripts and call functions back and forth? But what you'll start realizing is that putting it in one script is fine if you're making a Flappy Bird, right? But if you're making Angry Birds, it's just not going to do it. There's a big difference between Flappy Bird and Angry Bird, right? So anything that's more complex will use some form of MVC in some pieces or the other. It's not that their entire game will always be around MVC. There are different variants of MVC. Like, for example, Android uses something called as MVVM, which is a one step ahead kind of evolved version of MVC. So, but essentially the core philosophy is the same, that your logic is inside the controller, all the UI stuff needs to happen inside the view, and all the data and the processing happens inside the bond. So the core philosophy still remains the same. So if you think about games like PUBG, right? How do they implement the 100+ different characters and whatnot? I don't even know how many characters are there, but games like League of Legends, Dota, how do they implement all these different characters without having to copy paste a shit ton of code everywhere, left and right? This is how, right? So let me just clean this up a little bit. Yeah, Vijit, I'll just go over the demo code as well, but it's more important to right now understand, since it's new for everybody. We'll cover that as well. That's there. Uh, Will there be more than one controller for each and every aspect of the game? So yes, controllers, since they're not mono behaviors, these are very lightweight objects most of the time. So you can create many of them. So I'm just going to explain that part now. So imagine if you're playing something like PUBG or something, right? Like League of Legends, Dota, anything that has multiple characters. So you can think of the architecture that we just talked about. Each triangle of three basically represents nothing but one character on screen. Okay, so there's a controller that's controlling when you press the fire button, what needs to happen. When you activate an ability, what needs to happen. All that logic is inside the controller. But then what you see on the screen, that's the view part. Controller telling that, hey, I just shot a missile, right? And now the view needs to shoot something, right? So all that stuff is happening, and obviously you'll end up with multiple model view controllers, and each model view controller in itself represents one single thing, right? Be it a character, be it a vehicle, be it a, anything that's there. So anything that has anything to do with the logic. If it's just simply a UI kind of a piece, like if it has just a building, right? It doesn't have its own logic. You can most of the time get away with merging the controller and the view together and just creating, defaulting to everything inside one mono behavior, because it doesn't have much logic. If it hits something that destroys it, okay, destroy and done. That's it, right? But if it's anything more evolved than that, anything that needs to have some custom processing or anything, you'll need to probably do a separate class for a controller and a separate class for a view. Okay, so now think about this, right? So if I have a player controller and if I have a player view, I have a player model. Okay. Now, if I want to create, so my requirement is that I have, say, 30 different characters in the game. Okay, this is like 30 different players that you can select, or one of the characters, right? If I have 30 different characters, 10 of them are of one type, 10 of them are of another type, and 10 of them are of another type. Okay, so imagine something like 10 are like mages, and 10 are like snakes, and the other 10 are like beasts, something like that, right? So these are like classes of characters, right? And each 10 of them have their independent like models, independent animations, custom behavior. Some of them might even have custom logic. So assume that these 10 mages have the same logic, but they have 10 uh, different models that they use. Okay, and each model comes with its own set of animations, its own set of custom logic and whatnot. And the same goes for this as well, right? So you have 10, 10, 10, and this is a it's a small game. It only has 30 characters. So typically when you implement this in your existing approach, and if you wanted to create everything as a mono behavior, assume you're not using MVC, within a week, I can guarantee you that you'll be scratching your brains, because you'll end up with such a mess, and this project is never going to get done. Okay, so what we'll do is, essentially, here we know that there are 10 beasts, and all of these beasts have a very similar behavior. So we'll create a hierarchy of classes. Okay, so at the top, I'm going to just remove this. So at the very top, I'm going to have a player, rather I'm going to, since I'm calling them characters, I'm going to have a character controller as the base class. Okay, every character controller will have the same logic, right? For moving around the world and all those logic. Moving, say, jumping, imagine if it's like a Dota or a League of Legends kind of game, or even PUBG, right? So all that movement behavior, irrespective of who my character is exactly the same, right? So walking, jumping, all those things is exactly the same. So I'm going to implement one character controller for all of them. Now I'm going to create 3 inherited versions of it. One for the beast, one for the snake guy, one for the mage guy, or whatever, right? So like we saw inside that override functionality, right? So some of them may be, inside like a beast, just jumps from one place to another. So my walk would get overridden here, right? So now what I'm saying is that common functionality here, and these are custom controllers that define custom behaviors that a mage might have, like a shoot a fireball, right? But a snake might have a sliding animation or something, right? So those custom behaviors will be all inside here, right? And then I have 10 different views, right? That each represents one of them. So if I have 10 different types of beasts, each with their own unique animations and custom behavior and whatnot, I can create 10 different view classes. So I don't need to duplicate the walking logic or the jumping logic or anything like that. All that stuff is inside this. The views will have like the shoot, what happens when I shoot, if there is a custom, say a particle effect, right? Things like that, anything that's visual. So I can have 10 different views for beast. I can have 10 different this thing for this, and the same here. So now you see, with less number of classes, we were able to reuse a lot of this logic and still be able to connect the dots, right? So essentially, the moment, anytime you have this kind of a repeating pattern of things, MVC becomes the core choice of what you want to do. And in games, it's very common because a lot of the time we want to write code once and we want to be able to reuse it, right? So that's why you see a lot of these games that have different skins, right? Because creating skins is cheap, but you don't have to create anything new, more new code, right? At worst case, if you're creating a very custom skin or very different, right, all you end up is creating a new view class. That's it, right? And whenever somebody is using that skin, you give it that view class instead of the default view class, and that's all, right? No controller logic needs to change, no base logic needs to change. Your rest of the stuff is exactly the same, zero changes. So every time you see this pattern that I'm going to add a lot more elements to this particular game over time, but the pattern still remains the same, MVC is a perfect fit for it. Yeah, exactly. So, anything that has like a skin or, custom behavior, or, your core character is the same, but suddenly you unlock like the gold version or the diamond version or some bullshit, right? So the way it works is they just change the view classes, right? The controller is exactly the same. It's not like you're getting new functionality, right? If you take League of Legends, you keep getting these new skins, right? And these skins have custom animations, right? But your character's core mechanics don't change. Their abilities don't change. Their abilities do exactly the same. Their animation might have different, particle effects or flare or whatever, right? All you need to do is change the view logic. Whenever you change the view logic, you just get a new complete effect, and to the player it looks like, wow, this is completely new shit, right? So this is how you typically design a system. And this is when I say this has nothing to do with game design again, right? This is all we're talking about is how to design our code. So tomorrow a designer goes and says, hey, today I told you that I'm going to add 30 characters. Oh well, oops, we're going to add 300. Good luck if you created 30 more behaviors. Good luck now creating 300, right? So they're not going to care about this, right? Ultimately, it's you and me who will have to care about how much stuff that they need to write. So if you had architected it the right way, all you said, oh, okay, great. Just tell me what are the core differences. I'm going to put them in buckets. And if I need to create a new view for it, because it has a very different logic or a very different animation or anything like that, I'm going to create a new view class. Otherwise, it will probably fit into one of my existing view classes. And your designer is happy, and everybody gets a promotion. Cool. All right. So hopefully that gives a good picture of the power of MVC. Actually, one more thing I forgot. So that's typically how MVC is. Give me 1 second. Okay. So there's another thing, and this is something that I personally use. Not every company / every senior engineer, lead engineer would use it, if they even are using MVC. So I extend MVC with this concept of an S. And what S stands for is a service. So this connects us to a singleton. So essentially, inside my MVC, nothing ever will be a singleton. If you're doing a singleton inside an MVC, thinking, oh, I'm going to create this controller and that's a singleton, you're probably doing it wrong. You're 99% doing it wrong. So, okay. None of this stuff inside MVC can ever be a singleton. Because like you just were discussing, right? This is characters, they'll get created. Next time when you go into the game and you come back out of this game, you might select a different character. So there is never going to be ever a scenario where you create something as an MVC and that's a singleton. So S is basically what stands for service. And what is service? Service typically is the highest level of logic that controls everything. Okay, so typically how you will do is, so S stands for service, and this service is most of the time a singleton. Abhinav, why only one design pattern? Or you can use, so okay, Abhinav, this is just the first class, don't worry. This is just an intro to getting started. I'll give you guys a link of a book for design patterns, and this is the design pattern specifically to games only. It's a free book. You can buy it on Amazon, but there is a free version as well available that you can read, and it's the holy grail when it comes to design patterns. So essentially, a good 50 to 60% of the entire course that I teach is nothing but design patterns, because the moment you start using them correctly, the level of code that you write and the level of games that you make is gonna be 5 times better, even more. And you'll be surprised how many people end up using it. Nobody fucking uses it. Going back to service. So what this service does is it manages the entire MVC within its vertical. So what I mean by that, so imagine if your game, so anytime you made a game before, right? Just think right now. So what are the core pieces that you created inside the game? Probably there was some UI. There was probably some, player preferences thing that was managing writing high scores and whatnot. Then there was something like a game manager, right? So whatever is the highest level of abstraction inside the vertical. So I'm going to divide each of these pieces into its own verticals, right? So my lobby is one vertical. My in-game UI is one vertical. Player preferences, I'm going to call it as like the save system. That's my one vertical that takes care of saving all the player data, right? My actual game logic, like if there's a timer running, how many players, when to spawn, who to spawn, etc., team, all that stuff is like another thing. Then there's like probably a game over. So these are all verticals, okay? So each vertical, the highest level thing that controls it is a service. So there's going to be a game server. Typically what happens is people end up using something called as, if you've ever created like a game manager, right? It's essentially the same, except that services is a slightly more unified way of saying it. Managers aren't really great in general, and they become, but it's a nomenclature thing. So services is something that you should try and consistently use across the board. So you have a game service, you have a save system service, you have a UI service, you have a lobby service, you have a game over service, anything like that, right? So tomorrow you want to add like achievement system, right? So there will be an achievement service as well, right? So anything that's a service is the highest level thing inside it, and this is the thing that will be the singleton inside it. There's nothing else in that particular vertical that's a singleton. And anything under it are objects that are created on the fly when they're needed, and they get destroyed when they're done, right? So typically for like, let's say the game service will create player controllers, right? And player controllers inside it will have the player models and will have the player views, and these will keep getting created and destroyed by themselves. So you don't need to worry about them. So all this stuff is temporary. When something enters the game, they tell the game service that, hey, the game's starting, it'll spawn the players, right? And this is the game service is the one that will actually call new game controller and pass it the right things. So this is the singleton, this is the singleton, this is the singleton. Under it, nothing is a singleton. Under it, nothing is a singleton. Okay. So let's say if inside the lobby you have the play button, you have the quit button, you have the settings button, you have a lot of these buttons, right? So these can be typically directly uh, uh, views. Say, so if it's a single play button, it can be directly a view. You don't really need a lot of controller logic, because the moment you click play, you just tell this lobby service, hey, lobby service, somebody click the play button, so just play the game, and service will then take care of communicating. The best part is, since services are singleton, services can talk to each other. So this service can talk to each other as well, but this can never go across. This is not allowed. Okay. Hopefully is clear. But the idea is that anything inside it, anything inside this particular vertical will never cross talk into other verticals. So anything that's player controller will always talk to the player service or the game service, whatever you're calling it. Here we're calling it game service. So it will talk to the game service. And then the game service will talk to other services. So tomorrow, if I change another service, I don't have to change my game controller. Tomorrow, if I go and change my game over service, when my player controller dies, it doesn't go and tell the game over service that, hey, the player is dead, game is over, so start showing the game over logic. No, my player controller will tell to the game service its own head that I'm dead. Now you basically go and tell other things who needs to do what. So all my player is doing here is it's going to the logic and saying, hey, I'm dead. And that's it. That's all the player cares about. Hey, I'm dead. I don't know what needs to happen. Do I need to show an ad? Do I need to show an in-app purchase? Do I need to wait 5 seconds to watch an ad and revive? Don't care, right? That's the logic of game service. So game service will be the higher level logic that knows about the game behavior. So this will go to the game over screen if it needs to happen, or there might be an ad service that needs to show an ad. So basically the point is the highest level logic can talk across each other, but under it, you cannot have cross linkages. Okay. So this is the conceptual design that keeps things separated so that you do not end up with with a spaghetti code, basically. So what would have happened if there was a play button here inside the lobby? Instead of telling the lobby service, it directly talked to the game and said, hey, somebody click play, just start the game. Tomorrow, if I change something inside this game service and I created another service for handling the play logic for whatever reason, I've broken it down. Now I have to go and change this as well. And I might have to change this, I might have to change this. But instead, all of these, wherever there is a way to play, all go back to the lobby service. And lobby services say that when the moment somebody hits play, I'm going to go and do my own logic. So all I need to do is when something changes, I just need to change this lobby part. I don't need to change any of these further pieces. So each vertical pieces inside it are limited to talking to each other and the highest level piece, that's it. They don't cross talk across each other. Okay. The best part is that the moment you understand this, most of the time you will end up creating a modular game where you can add pieces later on. So this is something that you'll have to use a lot more design patterns to implement. Just MVC alone is not enough to do this. So this is what I'm just explaining theoretically as of now, how you should be thinking about creating your code, what classes to create, what singletons to create, what controllers to create. So this is how you normally think about it. Okay, cool. Let me know if there are any questions. Raise your hands or type them out. And we'll otherwise switch over to looking at some code snippets. Okay. Okay, so it looks like there are none. All right, so let me share my screen once again. All right, cool. So hopefully you can see this screen again. So I'm gonna close. Okay, so here you see there are a bunch of these scripts that I have created. So actually they're pretty much just empty placeholders right now. There isn't any logic in there. And these are exactly the four pieces that we just talked about, right? So you have a one second. So you have a controller, you have its corresponding view, you have a model, and then you have a service. Okay. So that's straightforward, and these are all the core pieces that we just talked about. Cool. One second. All right. So first we'll start with the controller. First, like we said, this will not be a mono behavior. Okay. So this will just implement a constructor that will return something, right? That will return the object basically. We'll add parameters to this constructor because each, like we discussed, if there are 20 different types of tanks, it needs to take in data. So we'll just define what that data will be. Okay. And there you'll see like there are different ways we can do it. It isn't something that's always kind of fixed, but you can like make changes, use your best judgment. But the more you use it, the better you'll get a hang of it. Okay, so tank model, again, this is also a regular class, so this will not be a mono behavior. So this will also have a tank model data. So typically, so let's say if my tank has a different, say I need some int speed or something, right? So let's just use one variable for now. So or rather actually add float health. So two. So what is my tank speed and what is my health? So every time I'm creating a particular model of a tank, I'm going to define these two parameters, which basically makes sure that every time I'm creating a new tank, I'm defining what these particular things will mean. So good. All right. So what I've done here is quickly just use these shortcuts. Just use Visual Studio. So all this does is creates me a public property, and this is as good as saying private set. So if you're familiar with properties, all this is saying is this is a variable, but it's more than just a variable where I can define who gets access to setting it and reading it. So since this is public, if I don't define a here, then this means this is also public. Here I've been explicitly saying that it's private. That means set is private, which means nobody outside this particular class can set it. So once I have set it here, if I don't make any more changes to this, the speed will never change. If I want to create a different function for a speed, I need to create a separate function that updates the speed. So that's pretty much it. And the same thing here, right? So if I don't write it, it's assumed that this particular property has a private setter and it has a public getter. That's all it says right now. So now I've defined my tank model. So we'll go over to the tank controller and say that, so there are two ways I can do it. I can say directly taken a tank model as an argument, and then just, this basically I'll hold a reference of this particular tank model, and that's pretty much it. The other way would have been that I could have taken directly whenever somebody is creating a controller. I could have taken in the speed and the health, and called new inside here, and then stored a reference to it. Both approaches would have been the same. So the other approach, uh, it purely depends who you want to hold the responsibility. But let's go with this for now. Okay. So now this says that whenever I'm creating a tank controller, I'm going to pass in the model. So whoever is creating the controller has the responsibility for creating the tank model as well. So that's one thing. The other thing we need to do is we need a view, right? Since the controller is the one that manages the view as well, so now we need something to pass the view. So similarly for the tank model, we could say, hey, whoever is creating the model creates also the view and passes me the entire thing. So I don't need to worry about it. So one approach is I'm going to do something like this and say done, right? So every time somebody is creating a tank controller, they're also passing me a tank view. But usually this is not a very good approach, because then that means is somebody higher level than this, and like we just discussed, right? Anything above the controller would basically be a service, right? So your service typically, so if this is your tank service, then this is the one that will have to create everything, right? So we'll just fix up the service, but this is the simplest way you can create a controller, but you don't want to usually do that. Instead, what you want to do is you want to say that I'm going to take some data, right? Some data such as, I'm going to take a game object, let's say. This is just an example. And this game object represents the tank prefab. Okay. So this tank prefab will basically tell me what is the view that I need to create. So I'm going to actually do the instantiate here and pass in this tank prefab. Okay, so this is the game object instantiate. So we need tank. Okay, so actually one thing, I'll show you one more thing. So if I have, instead of putting the tank view directly, I'm going to say game object, and I'm going to create a local game object, right? Typically how you would end up creating a game object, right? So this is how you would actually go about creating a game object, right? But ideally, I know that this prefab, since it's a prefab, right? It will have this tank view mono behavior attached to it. So anytime I'm creating a prefab, I do not want to use, or rather anytime I'm creating an object from a prefab, I do not want to use this representation, because it's going to duplicate a game object, but then I also want this property to get used, right? I want the tank view to directly have access, right? I don't want to do anything with the game object. I want the direct view class, and that way I can directly call functions on it, right? So what I'll do is I'll call duo dot get component, your standard thing, and call it tank view, right? Something like that, right? So instead of this, use the other alternative, right? So you have instantiate. I don't know why it is not sure. One second, why is this? Derived class. So game object dot instantiate. Now this instantiate has, one second, somebody dropped out. Okay, sorry. So this instantiate allows you to specify a type. Now remember when we discussed this generics in Singleton, This is exactly the same thing, right? Here we are saying that, hey, game object, instantiate a new game object and return me the view attached to it. I'm going to pass it the same tank prefab, but this time return me the actual game object. So here, this is saying that you need to pass it a tank view. So I'm going to directly take a tank view here. I'm going to remove these two and say create a tank view, and this tank view is what I'm going to store locally. Okay, so once I have this stored locally, I can call later on functions on it. So, and this is exactly the same generics uh, implementation that we saw for the singleton pattern. Okay, so you have your tank view, you instantiate it, and when you instantiate, it's going to create a game object, and the game object will have a tank view script on it. So now we have a base controller that just creates it. Once it gets created, let's just put a debug log or something here so we can actually see tank view created, right? So now we have tank view, we have this model. Tank view class data type. I'm not sure, Abhinav, what you mean. Could you elaborate your question, please? All right, cool. Meanwhile, what we'll do is so this is the basic view, and all we'll do is we'll just implement the start method for now, and we'll put in a debug log here saying tank view created. Okay, so this is just for saying that I've just started a view and the view has spawned. Can you please explain the instantiate line? Okay, sure. One sec. So let's look at the previous way of doing things. So typically you'll see engineers doing something like this, right? Where this prefab is actually but a game object. So if I have this, I'm gonna change this so that it doesn't show me an error. All right. So if I'm creating a tank controller, I'm taking a model, I'm taking a game object, and I'm gonna say game object.instantiate. It's gonna create a clone of this particular object and return me this, right? So, and then on top of that, if you want to store a local reference of that particular view that it has just created, you'll do game object.get component, right? Much like how you would do game object.get component, a rigid body or anything like that, right? So, and then you're going to continue using this. This go is a temporary thing. We don't care about the reference. The game object is going to be there, but that we care about this thing. So essentially, this one line basically merges these two, right? All this is saying is even if you look at this particular piece, right? This go.get component tank view, this is a generic. Anything that provides within this angle brackets is a generic. All this is saying is that, hey, get me a component of this particular type. So I'm passing this type, and the same thing, just that people don't use it. Instantiate, the original version when Unity launched, they had this instantiate, and that's what everybody uses. But there is an instantiate that is much better, and it creates directly a particular view. Now the best, and you'd be like, hey, why are we even talking about all this nonsense, right? That is just literally one line change, right? I can just do it and not worry about it. But here's the bigger difference. So when I'm creating a tank controller, if I'm using this commented out implementation, even though your code says that this is a tank prefab, if I code it in another inside my tank service, instead of a tank prefab, let's say I pass it a bullet prefab, it's still a game object. It will still instantiate it, and your code will not show any errors, right? Because it's a game object. Unity says, oh, You're giving me a game object. In one script, you're calling it a gun prefab. In another script, you're calling it a tank prefab. Unity doesn't care about the variable name. It says, oh, it's a game object. I'm good. Versus here, now you're saying that whoever is going to call new on a tank controller, it's going to try to create a tank controller. He can only pass me a tank view. He cannot pass me a game object that has another script attached to it, say like a gun view or a bullet view, right? So this is safe. This is not, because my code will still compile if I create inside. Okay, so I'll show you. So if I inside my service, sorry, inside my service, so let's say I'm going to create a start function here, and I say tank controller, new tank controller, okay? And I'm going to pass it, I'm going to create a tank model is equal to new tank model, and I'm going to pass it a speed. Let's say a speed is 5, health is say 100. That's it. So I'm going to pass it this particular model, and I'm going to pass it a prefab. Now ideally, if I'm not using this prefab version, this one, let's say I was using this game object version, right? So what I can do here accidentally is, this tank service is a mono behavior. It's attached to a particular game object. I can directly say game object here. And Unity will not show me an error. C# will not show me an error. Why? Because my tank controller constructor says I need a model and I need a game object, right? From the outside, that's all I care about. I need a model and I need an object. And this service passes me a model and it passes me an object. So my compiler will not have any issues. Now, when I run this code, so I'm going to comment this out. I'm going to use this approach, right? Now, this at runtime will throw a null pointer exception because I passed it an object that didn't have a tank view script attached to it, right? So at runtime, this will make my game crash. So you are not able to test these issues beforehand, okay? But if I was using, say, this implementation, right? And I was not using this. So I'm gonna comment these two out and uncomment this. So if I was saying that my tank controller needs a model and a view, now the service will have an error. This won't even let me compile. Forget about building the game, running it on an Android device, and then seeing that it crashes. Here itself, it shows me, hey, I cannot pass it a game object. I need to pass it a model, right? So now I need to define something that basically has a reference to a tank view script. And this is where the beauty of it is. So I'll create a tank view public variable that we'll just assign in the inspector, and I'll pass this tank view here. And that is why here also I could have done public game object tank view, right? I've created a variable saying tank view, but I'm accepting a game object. My designer, my teammate or other programmer, whoever, can accidentally drag and drop a different game object, right? And say, oh, it's a game object. I just drag and drop a game object, and it's a tank view. Maybe they even attached a tank view, but the script is not there, right? They created a prefab that looks like a tank. They just forget to attach the tank view script on it, right? And then this particular thing will show an error at runtime. Sorry, this one will crash at runtime, right? So here what we're doing is, by not creating these public game objects, but instead saying public tank view, I'm forcing everybody, whoever is setting up the scene, whoever is creating the scene or whatever, right, to make sure that they're setting up even the inspector correctly. Okay, does that make sense? So this is the most simplest thing that you can make, that you can do to make your code safe. Okay, so these are general practices. I'm not even going into any advanced Unity stuff yet, right? These are basic steps that you can make that others cannot attach wrong game objects. So now I'm gonna switch to Unity. Uh, can you guys see my Unity screen? I think, okay, one sec, let me change the sharing settings. Okay, now I think you can see, right? Okay, cool. So, okay, so I have this basic scene, and I'm gonna do is I'm gonna create um, an empty game object. I'm gonna call it just a tank or whatever. But the idea is that, let's say if there is a prefab as well, right? So there's this tank, create another empty, create a cube. So this cube is, say, the tank view. Okay, we don't really care much about what this is as of now. What I want to mainly show you guys is how this will work. So now this is a tank view. Now on this particular thing, I said I'm gonna attach a tank service. Now this says tank view, and anybody, any designer or anybody who's setting up the scene will say, oh, this is a tank view. So this object looks like a tank view, right? So I'm gonna drag and drop here. But oh wait, because its type has been defined to tank view and not just a generic game object, I cannot even drag it in here. It won't work till the time I go and attach the tank view script on it. Now you see this tank view script is here. That then only Unity will let me attach it here. So even accidentally, I will never set up wrong stuff. Okay. So now I have the service that has a tank view, and if I hit play and I remove this particular tank view object on it, if I hit play, it will create a new particular object for me. And here you see a clone getting created. It's disabled because this particular thing was disabled, but so let me just enable it and, move it here. Say, so assume I've created a prefab out of it, right? I just created a prefab and I deleted it from the screen. Yeah, you can use the require keyword. Problem is, writing require is a runtime thing as well, right? This is clear. So if there are, hundreds of different objects, engineers usually at bigger games will not go and create these, right? Somebody else would. So you've written the code, and imagine you're working on PUBG, right, where there's so many characters, so many different customizations and whatnot. Just that part of managing all these different players and their prefabs and whatnot is a full-time job, right? And that's not most of the time an engineer's job, right? It's morely somebody who's either a technical artist, somebody who's a designer would probably be doing it, right? So you do not want to make their life miserable because they'll come and ask you every time. So now you have this particular view and you can just drag and drop. Wait, what happened? Yeah, this has tank view. One sec. Okay. I don't know why it didn't drag first time. Okay, so now you see I have attached a tank view, and yes, of course, writing it also is tedious. But I think there is a bigger thing there as well, right? Not just saying require. Require is good for a lot of so require is good when you're doing a lot of Unity stuff. So let's say my tank view is it's, say my tank view needs an image because I'm making a 2D game, right? So if somebody has not created an image on the object, they cannot attach a tank view. Then you can say, hey, require component image. That way, what happens is that if somebody has created an image, attached a tank view, and later for some reason they were playing around with it and decided to remove the image. Unity won't let them remove that image. Unity will say that, hey, you can't remove this image because tank view needs this image. Okay, so there are use cases where you want to use that required image, but overall, as a generic pattern, this is the best practice, because it's clear to anybody who's setting it up that you can only drag and drop a tank view here and not any other game object, right? Because imagine if this service was again this particular thing, right? It had this game, I'm just going to call it wrong tank view, so it's clear. So if this wrong tank view is what I was ending up passing inside this particular controller, so this I could have freaking dropped the main camera in here and it looks good, no compilation error, nothing, right? But this basic stuff can actually make a lot of difference when you're building bigger projects. So you don't want to do this kind of things. So now you have this particular thing, I hit play and you'll see a tank view object get created. So you see the box on the screen and this is the view, right? Now the beauty is that there is a controller in memory as well. So you see the log message, tank view getting created. Actually I gave view in both the log message, but the point is one is coming is from the service, the other one is coming from the actual view. So the beauty is that there is a controller class as well that's not even a mono behavior, and that's going to do all my logic. Okay, so if you see here, this particular controller object, this exists, right? And I can, read input or do some processing or do anything on top of it, and it will have all my basic logic. And this does not even need to be mono, because the moment you define something as a mono behavior, that alone makes it a huge object, right? Not just that you need a game object for it to attach to and be able to run, but I don't know if you've ever tried to going to the mono behavior class as well. Let's see if we can. Yeah, you see, so this particular class has, so this is just the DLL, so it isn't showing you the implementation. Okay, let me see if it shows the C#. Yeah, so it's just basically doing a lot of, so this is like an entire logic that becomes inside, unnecessarily added to the particular class where you don't even need it, right? You just need a freaking, 20 lines of logic to run your particular controller, and that needs to have basic logic, whether my tank needs to go left or right, and tell the view to go left and right? So try to reduce the number of mono behaviors, and that in general beneficial for you for both from a managing perspective and also making sure your architecture is clear. So now you've seen a basic implementation of model view, right? So doesn't seem very scary once you understand what we were talking about on the board, right? From an architecture perspective, whenever you're sitting down and creating a new particular thing, you should be able to think about it in blocks, right? Okay, this is my controller, this is my model, this is my view, this is my service, and that's it, right? So you have a particular service at the top, and that service is creating this tank. So imagine if inside the service there was a public function that said public void start game, right? And some other service like the service lobby calls start game. Now all this particular thing needs to do is create a new tank, right? And what he can even do is we can abstract these two things away inside another function as an extract method, and I'm going to call this method create new tank. Okay, so I've created this function called create new tank. Okay, sorry. Yeah, so I've created this new function called create new tank, and I can even say, hey, this particular thing returns me a tank controller. So I'm going to here say return tank controller. Sorry, not this, tank. So now if I put this inside a for loop, right? So I'll end up with just this small loop. I can create any number, let's say 100,000 or whatever, right? I can create 1,000 controllers, and each of them represents a tank, right? And then, uh, sorry, uh, yeah. So here you see that now this particular thing lets me create this tank, and I can probably store it in a list or something so that when the game is over, I can destroy them, etc. Okay, cool. Seems like there are some couple of questions in the chat. Required keyword can also be tedious. Absolutely. Tank view, instantiate tank view, game object prefab here, instantiate the game object prefab and gets the component tank. Yes, exactly. So it will create a game object of the prefab that you have defined, and it will give you the view on top, basically. Okay, cool. So that's essentially, every time you see like things like bullets, items, anything, that has this common logic, you can more or less create a model view controller pattern for it. It might happen that, hey, if this something doesn't have a lot of data, right, you might not need a model. So you can just say, hey, this just needs a one variable or something. I'm just going to keep it inside the controller. So I'm going to reduce the number of scripts that I'm going to use, but I'm going to create a controller and a view. View is going to be taking care of the UI. And that helps us that if somehow tomorrow your entire view changes, your entire UI changes, then I don't need to change anything inside the controller. My logic has not changed. Just my visuals have changed. So I just change the view. Widget saying, so basically TK has a reference of tank view, right? Yep, exactly. So if you look at this particular thing, so this tank view holds a reference of the newly created view. Okay, and I'll show you one quick trick here. So anytime you have this debug log message, right? You see Unity shows this pop-up saying you can actually pass an object to it. So you can actually pass this tank view to it, and what this will do is, this is just a debug log, okay? So I put this debug log. Whenever a tank controller gets created, at the end of it, it creates a view, and the view is basically this. So now if I switch to Unity, I'll show you this neat little trick. Okay, so now you see there's only this main camera and there's this tank prefab. Sorry, tank service. Now what will happen is it will create a wait, did we disable the logic or something? One sec. So service, we created start game, sorry. Start game, yeah, thanks Naveed. So we called start game, and now actually 1000 is too much. Let's just reduce it to 3 or something. Okay. So now we'll go to Unity, and what you'll see is that it's going to create 3 objects, right? And you'll see 3 log messages as well, right? So you see these 3 log messages are tank view created, not the last one, the first 3. But remember, we added that particular thing at the end, right? So what will happen is the moment I click on this, now see the hierarchy. When I click on a separate log message, it highlights the game object. Okay, the one that's currently the one that I put inside this. So now, even though this message is the same, I know this message, the first message is coming from the first tank view clone, the second one is coming from the second one, third one's coming from the third one, right? This is just like a handy thing to debug. So imagine if, on some of the bigger game projects, you might have thousands and tens of thousands of objects in the hierarchy. And if there is an error, you quickly want to jump to that particular game object. And, oh, now I know. So let's say if this third thing was an error, I know, oh, okay. So Unity will highlight it with yellow and jump to it. So I can click on it and see, what my inspector is showing, or, I can try and debug faster. So it's just a quick sort of a tip on how to debug your code faster. So inside a debug log message, you can actually add any kind of an object. If it's a game object or a particular mono behavior, or anything that's attached to a game object, Unity will jump to it. So if you had a reference to a controller, a collider or something, Unity will directly jump to it. Cool. So that's pretty much more or less what I wanted to cover for today. I know since Singleton was a thing that you guys are already probably familiar with. This is not you know and one more thing is probably like the service will change to a Singleton rather than this, but we didn't create multiple services, so we didn't really need to showcase it. But the idea is that tank service will also become this thing, uh, a singleton basically. And I always use this mono singleton. So now if earlier people who were getting confused a little bit about what is this generic stuff and single brackets, everywhere you see these arrow brackets, even when you're creating this object instantiation. And if you go through Unity's doc, right, you'll see this particular thing getting used a lot of places. And this is actually if you see this version of it, always use this version of it, because here, instead of saying like, passing a string of tank view inside it, Unity kind of supports both APIs in most cases. This one is a much more optimized version of it, because anytime you're doing a string, right? Anytime you're passing a string, Unity doesn't know that this string maps to a function in a specific place. So it has to go and find all the functions and figure out which one the string and the function name matches. So anytime you're using any Unity API and you see this generic implementation of it that takes a direct type, always use that. That will always be better versus passing a string. And the most common example is a coroutine. So if you have a coroutine, you say start coroutine, and you pass it an actual string name, a string of the function name. That is a worse implementation of you calling the start coroutine versus the other implementation of start coroutine, which lets you basically call the function inside it directly, right? So people who are familiar with coroutine would know about it, right? So the second version is much better than the first. Even though coroutines are shit, people who will be going through the course would know. This is the first thing I tell you on day one, that no coroutines, no invokes, no creating mono behaviors left and right, because if you do, you'll probably get kicked out. So yeah, so that's pretty much a basic understanding of it. So here's an assignment for you. You can go to github.com/outscale. So this is typically everybody who's starting our batch. This is the first project that you start with. So you'll see a battle tank game. I'll actually put the link in the chat so people who don't have the link can directly hit this. So all the project work from previous projects, etc., is here, so you don't need to worry about anything. So the first, portion of our course that I teach predominantly focuses very heavily on game design patterns. These patterns will make your life easy. It will let you do things that you thought would take you years to do in literally weeks. So the assignment for you is to refer this battle tank game project. It is nothing but, if Unity has a battle tank game, this is exactly that, except that I've taken it and removed all the code, right? Because we don't want to use Unity's code. Unity's code is absolutely so we want to do is we want to implement our own version, okay? And again, the goal is, like we were talking about MVC today, you'll create a service that lets you create new tanks, and you'll spawn these tanks through different models and different views, okay? So potentially, I can go and actually start creating any number of tanks, and later on, we'll even look at some of examples where once you set up as a programmer, your designer can go and create 1,000 different types of tanks without even making 0 line of changes of code, right? there are techniques that you can use that will actually ultimately, as a programmer, so if I'm doing any kind of development, my job is to give the team enough tools for them to work independently, right? Because the moment a designer has to come to a programmer, that becomes a time waste for everyone. So, and also you don't want to keep writing, hey, programmer, today I need to create a blue tank. Can you create a blue tank for me? I was like, fuck it. Yesterday I created a pink and a green and a yellow. Now you want a blue? I'm going to waste half my day doing that, right? So you don't want to do unnecessary repetition, not in code, not in game. You don't want to repeat anything. So MVC is the classic example. Of course, MVC is not the only one, right? So you'll be using a lot more other patterns as well. Cool. So that's pretty much from today. What I can do is, um, if anybody has questions, I'm going to stop the screen share for now. Unless anybody, if somebody has any questions or anything, they can just ask. And I'll share the screen again. Okay, cool. So raise your hands if there is some question that you want to ask, and I'll let you, I'll just help you unmute your mic, and you can actually do a chat rather than type it out because it takes a while. So does anybody has a question? You can open up your video or anything. Feel free, and we can have 10, 15 minutes conversation around anything that we've discussed. So this was supposed to be kind of like a first introductory thing for people who are interested in the course that I'm doing, and kind of get a hang of how we do things, what kind of stuff we will be working on. This is the first time we are doing a weekend version. So it'll be kind of good to figure out what, so that there are a lot of people who are, surprisingly, actually people who are QAs at EA have reached out and want to do, because they now want to switch to uh, programming and actually developing games. People who are producers are pinging me as well. So there's a very mixed crowd. The only common factor is that everybody has to do a coding challenge. So it doesn't matter if you are 3 years experienced. It doesn't matter if you are 4th year in your college. When I review your code, you go through a technical process, you go through a non-technical interview. Everybody who goes through this particular course, since it's more advanced, everybody's at that same level, right? And my job is to bring you up to that level, right? So that's the goal here. I could have made YouTube videos, and that's something that I'm thinking about as well actively. So please do leave your feedback if that is something that you think helps. I personally don't feel that just watching videos and learning from there doesn't help. You need to have a more of a group experience working on projects together, and that helps a lot. So our previous developers are literally all got placed. So 3 of them got like 14, 15 different job offers, and that is when we stopped taking more companies. So there is, and frankly, right now, what I have like 12 people right now in this session, and there are more than 18, 19 companies right now who are lined up and asking when our next batch is graduating. So the problem is that the good developers in this market are really hard to find. But unfortunately, the sad part is that people are not willing to put in the time and effort to learn. Half of them are like, hey, I already got a job as a developer. Why do I need to learn more? Like, I'm doing this for 10 years and I still learn every day. So it's kind of sad that people have lost the touch to learn. But yeah, cool. So anybody has questions, please raise your hand. I'll just quickly look at the chat. How are you planning for all the classes for those who are doing jobs? So yeah, cool. Good question. So Abhinav, like I said, classes will be on the weekends during the evening hours. That way we can try and accommodate the most people. I've not finalized the time yet because the final list of people who will be going through the batch is not finalized yet. It will get finalized in this week. So people who like this particular session want to continue working with me. Ultimately, the goal here is to make you better developers and make companies chase you rather than you chase companies. Because I definitely feel that developers, are really hard to find. Good developers are really hard to find. So So once we have a good list of how many people would be going through it, um, we'll basically figure out a way, and most likely it will be Saturday evenings would be the lecture. The lecture might be a little longer than this if you want to create content for a full week, so that you guys, whoever has time, can continue working on this assignment. And we predominantly use Discord for a lot of our interactions. So there will be dedicated teams that you will be put into, and those will be your immediate members. Everybody will be doing their own code, but that team is going to be the first point of contact that you'll reach out to. So if something is not clear when you're implementing MVC or anything like that, for example, right, and something is not clear, you first will ping it in your team chat, right? And I'm looking at hiring a couple of TAs as well who will be available online to help you guys as well. Problem is, I'm looking at people who have 5 years experience and still don't know the shit. So can't even hire them as TAs to help people like you who are going through this program as well. So I need to teach them first in order to be able to help you. So those are my challenges. Cool. Please share the link for the book on the design patterns. Oh yeah, good question. Let me look it up. 1 second. It's called Game Design Patterns. No, sorry, not that one. 1 second. 1 second. Game Design Patterns. GameProgrammingPatterns.com. I'll put the link in the chat. This, I don't care if you join the course or not, but if you're going to take anything away from the 2 hours you spent today, read this book. More than read it, implement it. The guy is really, really good. I would even encourage you to, if you can, definitely buy a hard copy of it from Amazon or in a local bookstore or something. But there is a free version that you can read online. There are a lot of patterns. More than 2/3 of the patterns don't get actively used, but it's good to know about them, because they're more specific to certain specific scenarios. So they aren't necessarily something that you'd use every day. So Singleton is something that 99% of the projects use it. Second class would be more about how to not use Singleton. You'll learn 4 more design patterns on. So actually, let me actually add that as well. So today we learned a lot about making singletons prettier, easier for us to use. But at the end of the day, singletons are shit. They create a lot of that problem. Remember when I was talking about that things inside a vertical should not be cross-talking to each other outside it? Problem is that you might be disciplined to do it, but somebody else who comes along on the project would not. So they'll see an instance which is static. So, hey, I can just call this fucking thing anywhere. And they'll start calling it. So you'll end up having some controller talking to some other service or talking to some other view, talking to some other bullshit. And you'll end up with this spaghetti of, things pointing in different directions, and it's a mess. So the whole idea is that singletons are bad. And this, if you look at the singleton chapter from this particular book, that is the only chapter that tells you how to not use a design pattern. Rest every chapter will teach you how to use a design pattern. And that's the only chapter that will teach you how not to use a design pattern. So we'll look at some of the other design patterns as well in our further classes. That what are the techniques that we can use in order to limit the usage of singletons? What are the typical problems that comes with singleton as your project grows and the scope increases, and how you can manage, those kind of things. Those become very important. Cool. Interactive sessions are far better. Absolutely. Where can we access this lecture recording? I'm not yet sure. We are recording it, but we'll send out an email update once I figure out how and where we want to upload it and how we want to share it. So you'll definitely get access to it. But like I said, so you have the thingy on GitHub. You can start from there basically. Vijit asked, do you teach in batches? Yeah, Vijit. frankly, partly the problem with teaching is, it one-on-one is great, but a lot of learning happens in groups. So that's why I prefer batches, but batches would be more or less, between 10 and 20, maybe 25 max, is like the ideal size. So if you have friends or somebody who's experienced or starting, but not really just starting, but have some knowledge about game development, um, then yeah, definitely ask them to reach out to us, either on outscale.com. They can sign up there, or ping me directly on LinkedIn or anything like that. Um, and I'm happy to see. But ultimately, the goal is within this week, I want to finalize who all people are going through the batch. Because frankly, guys, if we end up with a batch size of less than 10, uh, I don't think we'll be able to run that. The only problem is that I need to put in a lot of time and effort as well, and it might not be even a great group experience for people who are going through the batch if you end up with like you're doing with 6 people, right? I have a lot of collaborative exercises in mind, uh, back from my coding days when I was in Silicon Valley. We used to do a lot of these coding exercises with matching up with seniors and juniors alike, and kind of, pair programming, mock programming, and things like that. So that's why having a decent enough batch size will help us, work on a lot of these things together. So I see a lot of names here in the chat already, that people who have already submitted their coding challenge, or people who have even interviewed already, right? So good that you guys were able to join. But ultimately we want to hit 15 to 20 people so that we can learn together over the course of next 6 months, and land you guys some rock solid jobs after that, where you're actually able to make some solid games. Cool. Think that's all I have, and definitely I'm thirsty. So if you guys are good, I think that's all for today. If there are any questions, quickly just drop them in the chat. Otherwise, let me know you're good, and we can call it a day. Feel free to drop me an email as well. If you have any suggestions on improvements, etc., how we did the session, if you felt like we didn't do something right or anything, or we could have done it something better. Maybe the lighting wasn't that good. This was like the emergency room that I was able to get. So feel free to just drop me there. If you're already connected on LinkedIn or anything, just drop me a message there. Most of you might already have my WhatsApp. So generally available everywhere, but yeah, the goal is this week I want to figure out how many people are seriously interested in dedicating time and effort to taking that next step up, and figure out a way from there. Cool. All right. Awesome. Yeah, I totally understand with it. The only problem is that that's why I said next week onwards, people who have committed to a full-time batch will, instead of being 2 hours, it will more be like 4 hours, where we'll actually give breaks in between to actually let you guys implement a few things, while we talk about it. So when we looked at Singleton, so we'll break for 20 minutes during the session, give you guys time to implement the Singleton, and if you're running into any issues with a basic version of it, you know uh, that way we can discuss it right now. Of course there will be assignments after that, but uh, even now, right? So we just wrapped up model view. Now you guys can start implementing on it, and we can take it more in an asynchronous manner, that for the next 2 hours we are still all available here, and people can ask their questions and whatnot. So today is just so that a lot of people have, they're coming from work, family, whatnot. That's why it was kept specifically for 2 hours, just to give you also a taste of how I do things, right? Because that's also very important, and I want to understand that people I'm committing time to for the next 6 months are also serious about this, right? So this is more of a, think of it as a teaser trailer kind of, versus a full session. So typically the sessions would usually be somewhere between 3.5, 4 hours, depending on the topic that we are covering and how detailed those topics are. So if later on in the project, when we jump to JavaScript, where we start working in Node.js and building multiplayer games, right? So for that particular piece, you'll be learning how to actually build from scratch, how to build servers. So I don't like using these pun and bolt and whatnot kind of things. So the whole idea is that you'll be able to build JavaScript. You'll be able to write basic JavaScript. So those kind of sessions might be even bigger. There's a lot more Unity stuff to talk about. We might cover those, etc., etc. So definitely, sessions will be much longer than typically this, especially since they'll be limited to just one weekend. Naveen, are there any scripts in the tank repo? Nope. There are no scripts. Like I said, intentionally remove them because I want you guys to implement your own versions. Before that, anybody who's not familiar with Git and wants to seriously consider this, or even don't want to consider it, take my advice for what it's worth. Learn Git first. Forget MVC, forget Singleton. None of this shit matters if you don't know how to use Git. That's the most basic fundamental thing. You drop game development tomorrow and start doing something else, you'll still need Git. So learn that first. There is another course. There's another repository on the same GitHub Outscal account called pre-course full stack game development, and that has basically anybody, if you know any students, people who are just getting started, that's the resource that they want to refer to, sequentially listed, and the very first topic is Git. So all free resources. If you're not familiar with any of those, start from there. All are like YouTube tutorials and whatnot, so please check them out. Widget classes will be held on Saturday and Sunday. Yes, Sunday I'm not sure if we'll do classes, but we'll figure it out. Sometimes we might end up doing half a class on Saturday and half a class on Sunday if the topic is very advanced and detailed, and I feel like you guys might need more time to think about it and do some exercise overnight and then do another class. So it won't be a mandatory Sunday always, but in some cases we will end up so it'll be more on a topic by topic basis, but you will know beforehand that this particular on the next coming Saturday and Sunday we'd have a class versus the next Saturday only is the class. So whatever it is, I'll communicate that beforehand so that you can also plan accordingly. And also if somebody's end up missing a weekend or something, as I said, classes are getting recorded. It's just that we'll figure out how to upload it and where to upload it and share it with you guys as well. So it's beneficial if somebody wants to read cap on it or something like that. Good. Any other questions? All right. I think I'm done talking as well. Tired. Cool. So let's wrap it up. Please let me know by Monday if any of you guys are interested. I mean, and this is for predominantly people who haven't already done their code challenge or haven't already had a direct word with me. If you're interested on continuing the full course as well. So take a look at the website. It has all the details. Anything's not clear, just hit me up. All right. Cool. All right. Thanks everyone for taking the time out. I know everybody has busy, so hopefully you guys learned something new today and will be able to make something good. Continue learning and cheers. Have a good weekend.